So let's take a look at the Tychos simulator. Let's look at the annual orbit of the Sun around Earth. There's Earth. There's the Sun. Now let's run this. Let me slow that down. Okay, so there we go. There's the Sun going around the Earth, and it goes in a counterclockwise direction. And we're looking down from on top, so this would be a northern hemisphere perspective. If you did it the other way, it'd go the opposite direction. If we go at 1,000-year clip, this will put the Earth into motion. This will make the Earth's speed 1 second equals 1,000 years. So now we'll see the Earth move. And when the Earth moves, the Sun goes with it because its orbit is centered on the Earth. And it has a clockwise orbit. Let's step forward. How much planar can it be? There's this motion, clearly a clockwise motion, and there's this motion, clearly a counterclockwise motion. For all intents and purposes, the Sun has 2 orbits, just like everything else in our solar system. You don't have to call them synodic, you don't have to call them sidereal. I don't care what the hell you call them. There's more than one motion. I mean, if there weren't, we'd be in a heliocentric system. Let's go to a second further demonstration. So all we have is the planet. So there's the Sun, here's Earth. You may be able to see there's the barycenter. I'll let that play now. These two are always in sync. That's why the equinoxes are always going to be in the same month. The sign will precess, of course, but the Earth and the Sun can't get out of sync because they're both traveling at the same angular velocity. They don't have the same speed. The Earth has a shorter route, a shorter circle, so it's going slower than the Sun. The Sun's speed is 2.64 times the Earth's speed, and so that's because it has further to go. It's going faster, but its angular velocity is the same. They're both the same. They have to be the same. If they weren't, the Sun would get out of sync with the Earth, and then it'd be chaotic. The distance between the Sun and the Earth doesn't change, but it appears that the distance between the Sun and the barycenter gets a little out of whack down here, but the Earth is still here. If I turn the Earth off, you'd be able to see that it's centered right here. It has to be that it's going with the Earth. This distance between here and here and here and there are equal. This distance from here to here is an AU, 1 AU in this model. So this entire distance, this diameter, is the entire diameter of the Sun's orbit, which is 300 million kilometers, plus the entire diameter of the Earth's PVP orbit, which is 113 million. So the total is about 400, and I'll put it on the screen because I can't remember what it is. But that, from that diameter, you can calculate the radius and the velocity for the Sun. So the Sun's velocity in this particular case would be over 5. So hopefully that's all too clear. If you enjoy this kind of stuff, come over to the Tychos forum where you'll get an opportunity to actually interface with the author himself, which is not a rarity in this world, but a singularity. So please stop in over at the forum and get involved in the conversation. May reason prevail.